and welcome to another episode of the Hambini Engineering Show, fronted by YouTube's most well-educated bicycle engineer. Those qualifications that I have, which are being able to read and use a screwdriver and have some common sense. Without further fannying around, let's start off with today's presentation. Now, this one was something that a lot of people requested, which was crap Cervelo S5, more fluffy aero bullshit from Canada via China. Oh, I'm not sure where. Actually, it might be Taiwan. But is that part of China? I've no idea. That may be an inflammatory comment for some people somewhere. It wasn't intended to be, but nonetheless, I'll continue faffing around. Right, by Hambini, aged 5, we need to check the pen is working. Now, if you are following at Cervelo headquarters, I apologise in advance. I did buy one of your bikes, and we will come to that in a minute. Right, the Cervelo S5. So this is the new one, released in the past few days. And it was ridden by this guy, Jonas Vingegaard. I can't really say his name properly. He won the Tour de France for the Jumbo-Visma team. Jumbo is the Dutch supermarket, and they do the best Stroopwafels ever. In fact, I think they're better than Albert Heijn, but there we go. So there's his bike. So that's been ridden around the Tour de France for a while, and now they've released one to the punters out there. I think, and I've read this in multiple places, it's $16,000 or £13,000 for a complete bike. That is ridiculous. That is absolutely ridiculous amounts of money. Anyway, we carry on. Right, my history with crap Velo. So, in 2013, I bought a Cervelo S5. So this same bike, but a few generations behind, from Merlin Cycles, who have just, in the past few months, ripped me off. And the bottom bracket creaked from the start. It was basically a bag of shit. So I had to make a new one. In 2015, I got laid. In 2019, I did a video which caused quite a ruckus because Cervelo were found to have been fiddling their manufacturing tolerances to allow for shittier manufacture. Then in 2020, Gerard Vrooman, that well-known bicycle engineer, tried to sue me and then dropped it. In fact, I have the x-rays. Fuck, where are the x-rays? Ah, never lose the x-rays. I always keep the x-rays. The x-rays, yes. Anyway, right. And then in 2021, in the spirit of engineering excellence, I chopped up my S5 to see how strong it was, and the answer was not any stronger than the $500 Trifox frame that you can get for $500, which is basically an exact copy of a Cipollini, the MB1K or something like that. Anyway, right, this is the black bike here is the 2022 S5, and the 2023 S5 is the red one. You'd be hard pushed to find a difference, so I've sort of circled them for you. So the first thing is, if you have a look at that distance there is bigger than this one here. Now there's the S5, this generation of S5 has a hinged front fork. So the front fork kind of swivels round here. So that's where the joint is. Normally it's a round tube through there. The round tube in this case is there, and the whole thing, the front thing, swivels round. The reason they've done that is it makes it a bit more aerodynamic. So if you're looking at it from above, it looks like that, and the swivel point is there. I think it's a way to get around the UCI regulations. The other thing is that bit I think looks a bit beefed up, but I'm not sure. To be honest, it's not really a big deal. And then you've got that bit, so they've put a gusset in there, reinforced section. Don't know why. And then finally, I couldn't tell if the front fork was slightly deeper. So the aerofoil profile was wider. I don't know, I couldn't tell for sure, but I just a guess. So they're the main differences. The other key difference is these, which are the Reserve wheels. Now Reserve looks like a partner company of Cervelo and Santa Cruz and a few other things. And what they've done is they've gone and started testing in turbulent conditions. Now they have a video about it, which if I've edited this correctly, I'll show you in a second. But there's also a bit on Cycling Tips. James Huang from Cycling Tips. In fact, he's one of the better journalists. He's talked about it and explained it. This is the crux of it. So the front wheel rim looks, I mean, if I drew the tyre on there, it'd be like that. And if I drew the tyre on this one, it'd probably be like, oh god, I didn't draw that one very well. Like that, something like that. And what they've said is, normally, and I've said this before, you know, computer models, wind tunnels, you are riding along in mathematically perfect conditions. As soon as you get out of the door and then go out onto a normal road, it's not like that at all. It's all wishy-washy and waving around the place. So they've gone along, Santa Cruz or Reserve have gone along and said, you know, we're going to go test in turbulent conditions, and this is what they've come up with. Now, to me, with my aero hat on, I don't think that's possibly not optimal. I don't think it's optimal. I mean, that's just the crux of it. Right, well, let me play the video. So this is the video that I was on about.
Tunnel testing for cycling has always been conducted under.
This is fronted by a chap called Nick McRae. He's a composites engineer for Santa Cruz. He comes across as quite knowledgeable in this video, give him his dues. And they talk about laminar flow, and these blue lines are laminar flow, so straight lines basically. And then a bit further along, they talk about this, which is turbulent flow, and then that's how they've designed their wheels and stuff like that. The thing with this is, you know, it's pretty obvious to anybody when they go out of the door that you're going to get turbulent flow in a road, street furniture, all of that. And the power of a wind tunnel to be able to replicate that is actually quite limited. You need a transient wind tunnel, and even then, it's not perfect. Now this video goes on a bit further and you can see the wind tunnel they've used, and to me it looks like a steady state wind tunnel where they've probably bolted on some paraphernalia to generate some turbulence. I mean, far from me to judge, although that's why people tune in. I don't think they would have the technical expertise or the processing power to be able to understand that fully. Now I'll take my hat off to them if they have got that. But you would really need someone from the aero industry who's into probably military aircraft, because they will be the ones that are flown in unsteady conditions, to be able to deal with that. I doubt that any Tom, Dick or Harry from university would have that experience. I mean, it's not taught at undergrad level. You're basically thrown out into the field and then asked to explain it. Now the methods he uses, pressure rakes, all that kind of stuff, were described by Alexander Dmitriev in 1978 when he did the MiG-29. So the methods they've used look to be totally kosher. He's probably read the same books, the standard text. Right. Now, one of the key things that Cervelo and all the others have done in the past is to, you've got a cumulative drag saving. So in 2013, between 2013 and 2014, we had an 8 watt saving. So that's what they said was faster than the year before. Then 5 watts between these years, 7 watts, you get the idea. Okay, the total saving, if you add all those up over the years, is 44 watts. Just be warned, I could have made a complete fuck up here but not as big a fuck up as the wanketeering department from the bike company. I mean, they've got all sorts in there. If you look back, they've got, you know, drag at X yaw angle. Then they've used drag quoted in fucking grams. Seriously, who the fuck quotes drag in grams? It's a unit of mass. It's not a unit of force at all. So you have to end up multiplying by gravity and then the velocity that you're traveling at. So there's a load of permutations in there, but you kind of get the idea. So between 2016 and 2017, that was a good year. I think that was possibly when they changed the handlebars, maybe. But anyway, it's a total saving of 44 watts. Now, if you go and actually, you know, work this out, to do 45 kilometers per hour, you need about 500 watts. You know, you could argue the toss, it might be 450 watts or 500 or 550. It doesn't actually matter that much at this point. 75% of that 500 watts, you could argue it's 60%, could argue it's 80%. Well, I've just picked 75%. Is a reasonable number. 350 watts of that is the drag from the rider. So that means the drag from the bike and its paraphernalia is 150 watts because it has to equal 500 watts. Now, fast forward to 2023, the rider drag obviously hasn't changed unless you wear women's clothing, but you're now at 106 watts. That is, you know, that's how much of the pie or the stacked bar chart that you've saved. All that. That is an unbelievable number. Now, feel free to comment below if you think I've screwed the maths up, but it is an unbelievable number. I mean, how can you get from 150 watts to 106 watts? That's all their cumulative savings. You have to have your CDA reduce by a third. It's just ridiculous, unbelievable. I'm not sure if they take us for stupid people or what, or have I done the maths wrong? I mean, I could have done the maths wrong. I am obviously, in the eyes of various people, a twat, but you know, that's what I think. Right, the other things that the shite people in wanketeering wanted me to mention. The wealthy fat fucker friendly 34mm tyres will fit in the new 2023 S5. The cockpit is simpler and stiffer, so Tyrone has asked me to go and get one. And this is a guess because I haven't seen it verified anywhere. It uses a BB shite bottom bracket, so you know you can go and look up all the stuff on that later. Right, now how does this stack up against the rest? Now if I was to highlight the similarities between these two bikes, you can see you got this, which one shall I draw on? I'll draw on the Cervelo. You can see the down tube follows the front wheel. It's the same thing on my BMC Time Machine time trial bike. That is a good thing. So that's an aerodynamic feature. There's this Cannondale that I've put on here is probably, in my opinion and in the views of some of my colleagues, in fact all of them, we've always thought that that's the best for aerodynamics by looking at it. But yeah, you can see that down tube, so that's why I've compared the two. The down tube follows the tyre or the wheel. You want to really minimise that gap. So if they've made it 34mm and you go and stick a 23mm tyre on there, you've probably negated the advantage. There's some advantage in other areas, but it's part of the course. The other thing is, I mean, you can see, you know, here where the rear seat tube and the drop seat stays are common to both bikes. Now, structurally, this is better because the seat tube is completely in line. Here, you got a curve. So in order to achieve the same level of strength, you would have to reinforce that quite significantly. The other thing to note, and it may not be so obvious, is the angle of the stays on the Cervelo is much more, is it obtuse, I think, versus acute on the Cannondale. But, you know, that's by the by. And then, you know, the key difference where you would, you know, notice a difference is here. So the Cannondale uses a conventional steerer. You haven't really heard of people, you know, having a design defect in the Cannondale steerer, whereas you have in the Cervelo because it hits the stops. So yeah, that's a key difference. So the profile there probably looks like that. I'm drawing this exaggerated, but on the Cervelo it probably looks like that. This is more aerodynamic. You want the taper angle to be, or the thickness to chord ratio, do you want that to be as high as possible in favour of the chord length. What else was I going to say? Yeah, the drag, I mean, this is where, I mean, it becomes really, really unbelievable. Both of these bikes are equipped with disc brakes. Now, if you look, I haven't zoomed in on here, but the disc, in a disc, you've got a bit of conflict of interest. You obviously need to stop the bike, but the disc gets hot, so you need to get rid of the heat. In order to get rid of the heat, you make it rippled in the sense that, you know, there's cutouts and things like that, so that it generates turbulence. Air is a crap conductor of heat, so you need a large surface area to get rid of the heat. By putting all those slits and things in there, you are generating, and then you spin it, you'll get what's known as a pumping loss. So a pumping loss is best described, I'm not even sure they measure it. So if you just you know, get on the bike and go in a wind tunnel, what happens is they usually put some force sensors, transducers, whatever you want to call it, strain gauges, however they want to measure it, whatever. Some people use lasers. Anyway, as the wind hits it, you are being pushed back and it stretches the strain gauge. The issue there is the front wheel, in order to spin that front wheel up, you're having to expend some power because that front disc is generating a pumping loss. So air's hitting it and it's being moved out the way. It's designed to suck air in and push it out so that you get heat loss. You know, you conduct the heat away, but that has it is a power loss. In a rim brake, you don't have that. You don't have that pumping loss because it's part of the wheel. Now that pumping loss is significant, and I just cannot believe that, you know, they haven't accounted for that. It's just ridiculous. In fact, I don't think they measure for it. Right, finally, the conclusion. I think this is a key thing, irrespective of the bike. Make sure you get a bike that actually fits you. Now, you adapting to the bike is usually going to be slower. So, you know, moving the stem, rotating the handlebars, the seat position, all that. If you just get on the bike and it all fits you, that's fine. If you're having to like duck around and stuff, you usually will get a slight power loss, backache, and quite more often than not, there'll be an aerodynamic loss as well. This bike is likely to be quite aerodynamic. I mean, looking at the pictures, you know, you've got the features to suggest it's aerodynamic. So, you know, I would be doing it a disservice if I said it's slow. I mean, Vingegaard's proven it's a fast bike. To be honest, I think he would have won on any of those bikes. But it looks fast. And, you know, the features on there, so the cutout in the down tube, the scalloped seat tube, all of that, you know, to an aeronautical engineer, that's what you would do. Now, the build quality. If I come to the build quality, historically, they have been crap. So if you just take the bottom bracket as an example, NTN and SKF won't warranty their bearings inside the tolerances that SKF supply. Sorry, I'll rephrase that. NTN and SKF won't warranty their bearings in Cervelo's B-Bright standard as it's given. The standard is 0.1 millimeters. They fudged it, I don't know when, to make it, to make their life easy, to give you better manufacturing tolerances. To make slacker manufacturing tolerances so that they could shift more. That kind of behaviour is pretty bad in the engineering world, but to be honest, they don't care, and most of the bike companies don't care. In fact, most of the bike accessory companies don't care either. But I care because that's engineering, and I think that's setting a bad name for engineers around the world. So there we go. That is the end of the video. I apologise for ranting like I usually do, but a load of people asked for it. So yeah, so in short, probably a fast bike. It's horrendously expensive, and I think you could probably do better elsewhere. But as always, keep banging your hairdresser.